Well, good evening, everyone. Welcome to class.
Good evening, sir.
Good evening, sir.
Well, welcome. Welcome to the almighty DevOps. This is DevOps. We say congratulations for getting to this level. Well, let's throw that till reach the module. Understand this, practice this, and then go all out confidently to grab your six-figure job. Confidently. Because I've not only compared the quality of training with the industry leaders, I've actually also gone to the industry leader as a student to more like spy and learn and bring in all of that knowledge, experience, exposure, and interactions with them to you through this improved DevOps course. And this is the first time I'm delivering this. January this year, I had an improved version. And then for the second time this year, I'm having this improved version, very much improved version. All right. If you are ready, let's start. Share screen. Where's my pen? Let's share. What can we share? Where's my paintbrush? Share pen. All right, guys. Can you see my paintbrush screen?
Yes.
Okay. So before we go into DevOps tools and practicals, let's first get an understanding of what DevOps is. We normally do. All right. Actually, let me open the note. Yeah. Can you see the note?
No, sir.
Okay. Yeah, let me just read the note right here. So share. All right. So this is your DevOps note. Well, like I said, it's mostly made up of raw materials that, like I said, have drawn from these other experts. So I'll be formatting and modifying them to what you can easily understand, copy and paste as it progresses. It's a modification of the old note, I split the old note. All right, so DevOps, let's start from the beginning. So when we say DevOps, what do we mean? So, yeah, you all have gone through Linux, AWS, infrastructure as code, which is awesome. Of all of the courses that you have gone through, and you can actually now begin to look for a job if you want. This is the real one that they need in the industry. They need you to be able to use Linux, the understanding of Linux, to automate the deployment of the provisioning of infrastructure in cloud using codes. All right, now what is DevOps? Let's go. Let me load my paintbrush one more time. So when you use the skill that you already acquired to deploy infrastructure, to provision infrastructure in cloud, I reserve the term deploy for application and provisioning for infrastructure. So when you go to cloud and you set up your infrastructure, basically servers, within your VPCs in cloud, and of course, with all of the additional services around that would, around both the server and the network to secure the infra in cloud. The next thing you want to do is put application. Just like we have said many times, that is the real reason. You want to put application into this infrastructure so that through the cloud, that application is now available globally to all your millions of customers. And because you know Linux, you're able to manage not just this server, but the entire enterprise infrastructure. So this whole VPC and everything contained within is your enterprise. When they say enterprise solution, enterprise network, enterprise this, enterprise, they are referring to that. Now, like I said, what we want to do is deploy the application in here. So that's where the work continues now. Because as far as provisioning of infrastructure is concerned, you are good with infrastructure as code. So you want to take it to the next level. And this is the next level. The next level is that some people, another group of IT professionals called developers, they are writing codes. 1+1, when the 1+1 equals, when I ask computer 1+1, it should always give me 2. And that 2 should be saved in the memory location I represent by V1. When I take that memory location content, they are just writing codes in whatever language. For example, in Java, programming language, they are writing codes. Once these codes are written as given to them by the client for whom you set up this infrastructure, for example, Tesla or Google, let's say Tesla. So this is Tesla developers from all over the world. Developers, they are not located in just one country. From India, from Pakistan, from Nigeria, from everybody. And they are writing codes. So as they are writing codes individually from different countries, from across the world, all of those codes are pushed to a central server where all of the pieces of codes are available. All right. This central server is what we call version control system. An example of such virtual server, like we're going to see now, is Bitbucket. That is one. And S3 can go be, but the one we're going to use and the most popular is GitHub. Where do I write it? GitHub. Right? It's an example of, it's actually the VSC, as VCS that we are going to use. So when they write these codes, and all of the codes written by the 3,000 different programmers, otherwise called developers from across the world, are pushed to a central location where it is available to you as a DevOps person, what you want to do is pull the codes from here and convert the code from just codes that they are here to application. So they come in as 3,000 lines of code, and they come out as just one, maybe 30,000 lines of code, and comes out as just one app. 30,000 lines of codes. And then they come out as a single app. This is called compiling, or more the modern language, build. You are building the code, build the codes into app. So this is the app now that you are going to put in that infrastructure that you had earlier on with all of this knowledge you have. And then, of course, like we said, it is not just a matter of putting that in the server, It's also a matter of configuring your Route 53, your RDS, your NACO, your security group, your AFG, and all of the different services within your cloud, so that these customers are now able to access this application with the right set of permissions that the company needs. You get it so far?
Yes.
All right. So whereas what you knew before now stopped at this level, we're now introducing this level. All right. So this part of the job that makes the application available to everyone is called operations, because this is in operation. Operations, not just this actually. All of this is operations. Operation. So your infrastructure and the provision is part of operation. So, all right. Whereas this other part that is responsible for building the code before you now pull the code and build it into app before you release to operations, this is called, like we said earlier on, development. So as the DevOps person, you are interfacing between otherwise there will be a barrier here. There will be a barrier so that every time development completes its own side of the work, they would need some approval, verification, scrutiny, security, and all of that long process that will make it impossible for that application to go straight into operation. While the DevOps person in between, you are removing that barricade. You are blurring that barrier, that wall. And what is the goal? The goal is for every time there is a change in codes resulting from development, that should be deployed instantly. In fact, without even any form of discrimination or demarcation between the two, instantly into operation. For that to happen, there has to be automation. Automation will now allow whatever modification is happening in code to automatically go into production, otherwise called automation. So with that background, DevOps, which is made up of development and operations, so we say development and operations. It's a concept, it's a methodology, it's the idea, it's the mindset that there should be no demarcation between development and operation. That everything that is being modified in code here should automatically transform into application, and that application should automatically, well, maybe not automatically at this point, should go into operations at we call it highest velocity, at very high velocity, so that, when you speed, velocity means speed, at very high speed, so that there is, in fact, the higher the speed, the better. So when we say, as soon as the modification is made here, the effect should be felt here, then we are saying that it should happen instantly. All of those English about velocity is just saying happen instantly. And for things to happen instantly from what you know so far, it has to be automation, so that the way it is done here is not waiting for somebody to come and manually pull some trigger before it goes. So DevOps is a concept, otherwise called methodology. Concept. What is the concept? The concept that as modifications are made to code, the effect should reflect instantly in operations. It's that concept. The same concept that TI used to call a 6S, and the same concept, or maybe very similar to the concept that the Japanese calls Kaizen. So it basically means continuous improvement. That this application would never get to a level where we feel, oh, finally we have reached the moon, or finally we have reached the stars. There is no more, there is nowhere else to go. We have no. No matter how beautiful, how awesome this Gogo is today, there must be something to do on this application to make it better. In other words, there is always work to do. And then once there is something to do on the application to make it better, you come back again to the beginning, and then you do that thing, the application is better. At this best stage, look for what else can be done to improve according to usually according to the feedback that you get from customers. And then it just keeps going on infinitely. That's why you have this sign infinite. All right. So it is the concept that will never end, will never stop at arriving at best. We continuously improve on the best to get something better. All right, so that is concept. Then what is the role of the DevOps person, or specifically the DevOps engineer? The role of the DevOps engineer is to implement, to make that concept a reality. The concept is just a mindset, it's just in the brain, it's just in the mind, it's just your wish. But to bring that concept, that methodology to reality, then the DevOps engineer has to employ IT tools, of course, chief among them Linux, automation, and then of course new tools that he can use to pull codes from here, use to build the codes, use to convert the code to app, use to do testing, and so on and so forth. There are so many things that should happen here, like we're going to learn before this application is finally ready for deployment to operations, or more specifically, production. It is the automation process and the tools that are involved in that automation process that we are going to learn here to make us DevOps engineer. Make us DevOps engineer. Did you get that overview of what DevOps is?
Yes, sir.
Awesome. So who can help him? What is DevOps? What is DevOps and who is a DevOps engineer? Or let me explain that. What is DevOps? Yeah. Then what do DevOps engineers do? What do DevOps engineers? Yeah,
I'll simply put it as DevOps is a concept to convert the code into operational instantly.
Okay.
Using automation tools.
Okay, so first of all, DevOps is a concept. And the concept is as often and as soon or as frequently as codes are produced, it should be converted. Where's that? Oh, from MVP, you have background. It should be converted to the app equivalent that the customers, the end users, and can see. Correct. So that is concept fine. Okay, so the other part now.
Okay, we can say they develop, they manage codes, test it, develop it.
No, the question is, what do DevOps engineers do? Not developers.
DevOps engineers.
Okay.
Yeah, let him start. Okay. Thank you, but let Demola continue.
Okay, they manage and deploy codes to the end user. So Okay, let him continue. I'll come back.
All right, you have the idea, but you just didn't use the right words. All right, so who can help?
So I can go. Oh.
I was going to say,
Who was the first person? Yeah, George.
DevOps engineers are there as a bridge between development and operation for continuous improvement, to use automation tools.
Yeah, that is good, but I need you to relate your explanation to the first. The first person told us what DevOps is. So put your explanation, superimpose your explanation on top of that concept of what DevOps is.
So,
but in any case, you were right, but I just need you to get that in. Yeah.
So DevOps engineers are able to utilize the concept of codes that are created by developers and use those automation tools to create an environment to continuously bring those codes to life. I'm lost.
In production. All right. Beautiful. Yeah. All right. So yes. So based on the concept of DevOps, which is to speedily push to production changes in code, the DevOps engineers are now responsible for making that happen. In other words, they know the IT tools to make that happen. They don't only make that happen, they also automate the process of making that happen using the appropriate tools, and the tools we are going to learn. All right. Okay, so somebody was trying to explain the place of developers in this concept. What do developers do here? Like, yeah, somebody already actually explained. You can orient. So what is the place of developers in this DevOps life cycle? It's actually DevOps, not software, not I'll explain the difference. All right, so what do developers do here? So developers write the codes that we build into applications. Without codes, no applications. The developers write code. Another word for developer is coder. All right, very important that you get that concept, which I think you've gotten, because that is the beginning of the internet. You don't even know what DevOps engineers do, then I should be interviewed. So it's important to realize, I mean, they keep emphasizing that DevOps is not the use of the tools, that DevOps is a concept, a methodology. All right, bringing that concept into life practically now involves the use of tools, IT tools. That is where DevOps engineers come into the picture. All right, good. Now, it wasn't always like this. DevOps is a fairly new concept. What used to be was that if you wanted to create a software, at that time it was called software, even application, the word application, replacing software these days is a fairly new concept as well. When I say fairly new, I mean all of this is modern age IT terminologies and technologies, not just that came into being. And yeah, some of them even as fresh as 7 years ago. All right. So what used to be was that if you had the concept to develop a software, you would go through, let me lose the note at this. We'll do less of drawing, have more time. Can you see my notes? Can you see my notes?
No, sir. No.
No? Okay, sure. All right. So what used to be is that apparently it's not on the first page, so I've seen it again. To develop a software, you will go to, you are the owner of the idea, you come up with the idea, like we already saw. You go to the people, somebody who you call to say, I have this software idea, please. Or actually, you don't even know at this level that it's a software. You just have this idea of, I want to create an app that would take care of transportation problem. Let's simplify it. And then you call somebody like me or like you who understands IT and is able to see the possibility of converting this idea to software application. So this person used to be called, I mean, this is old terminology now. This person used to be called the business analyst. All right. So this business analyst will understand your idea and then, oh yes, and then he will deduce specifications. They call them at that level, high level requirement from that idea. And then from that high level requirement, he will talk with other stakeholders and break up that high level requirement to low level requirement. And then it is this low level requirement in document form, requirement analysis, that is given to coders, to programmers that are now able to convert that into programs that would represent the idea. Whatever idea, dream this guy had in English language or in his imagination is now converted to the equivalent computer program. And then once that is done, it is taken to an environment where it is tested. Once the tested is done, it is now pushed to a live server, and then it becomes live, and then it is monitored, something like that, not strictly so, about 7 steps. All of this method was such that this process cannot start until this one comes. It was rigid. So this process of developing software, following this step, and then once that step is complete, we move to the next step. Once that step is complete, we move to the next step. And then once you are at this step and there is a change here, if this guy now decides, no, that was not the idea, something, it means that you have to go all the way and start all over again. In other words, all of your previous efforts will be wasted. This method of developing software, this methodology, not this concept, was called waterfall methodology of software development. Otherwise called software development life cycle. This, nobody uses this. Well, it's still there in the background, but what is more common now is a new method called agile. Agile methodology. They are all methodologies. So what's the difference? In agile methodology, we don't really wait to understand the whole concept before we go to market and launch our product, and then customers are now using our product. What we do is, once we have a good enough foundational idea of what we want to do, we go ahead and build the software, the application, based on that idea. All right? And then, even if we have is that fuller or more full, whatever the word is, a fuller idea, we may decide, yeah, why wait 3 years to build the complete software of the idea that we have right now? Let us build the first 1G or 2G part. Later, we can expand it to 5G, for example. And then they build the 2G part of the network and push it to the market. And the market likes it, or maybe they don't like it. And they use that feedback to improve and then build the 3G on top of the 2G, and then build the 4G on top of the 3G, and ultimately build the 5G. And that is even now. What about 20 years time? We might be talking about 8G and so on and so forth. So this concept of not building the whole software, but building the software in modules called iterations. Iteration. It's called agile So instead of the software being one rigid, solid application like waterfall, it is broken up into parts. In fact, the way it works is such that even if you remove this part of the software, it does not stop this other part from working. This part will still work, this part will still work. It's just like removing a part of the engine and replacing the whole module. So if this software goes down, you are not troubleshooting and repairing the whole software. You are just isolating the module, the part, the engine part of the entire software that has issue, resolving that part, and then bringing it back. So it's it's modular. It's modular. I mean, imagine that the engine of your car, once something happens, you have to replace the whole engine, move everything out, compared to the modular state where if it's just one part of the engine, you are calling everything in the whole engine, even though that's incorrect. So you just remove the faulty part and then you replace. That's how this one works. All right. So the difference here is that this software, this application is built in modules, usually every tools. All right. This is what Scrum people, this is Scrum. So this is what the Scrum manager or the Scrum master.
Master.
Yeah, the Scrum master, this is his work to manage the people developing this application, to tell, oh, this is the next, what you did 2 weeks ago was beautiful. However, this feedback is what we get. We need to change this, change it, change it. The next 2 weeks, we are building a new module on that. It's managing the software developers, the people we call developers earlier on, to work according to this methodology, which he understands. He's not the technical person, the developers are the technical people. All right. So this is about development of the software, of the application. All right. Agile methodology. So in the specification, your job description, they are going to mention, I mean, they might mention the person we are looking for, especially when it's related to software development. We are looking for somebody who understands the concept of waterfall, the concept, and is able to work within agile methodology. It's just English, no big deal. It's just English saying that this is the method, the methodology we follow in building our application. In other words, the work on our application will forever continue. There is always another module to build on top of the existing one, another module to build on that once it's working, another, and so on and so forth. It never stops. We don't wait for 5 years to get the foundation right before we go to develop. We are building, we are developing all the time. If there's any problem with the latest development, we'll resolve that, make sure it's fine before we move to the next one. But we are building anyway, right? In iterations. And then that's 2 weeks. They have they would. But the Scrum Master would manage the development team to work according to this. Now, this stops at development. Remember that there's another part of development. After the development, whatever is developed has to be compiled, the codes have to be built, and an application results from the build, and then that application is deployed to operations. What about operations? So there's another part beyond development that is called operation. All right. So once Agile takes care of development, we now need to push this app that is resulting from development to where? To operations. We've already explained what operations. So this is the work of the DevOps. So all of this together, including the Agile methodology and the deployment to operations until it is available in the market and all the customers. All the customers are connected to it. This is DevOps. Do you get the concept even clearer now? DevOps. So the development teams are developing codes using the agile methodology, and they are pushing the codes to you, and you are the DevOps person interfacing between this, is removing this boundary so that these two are now seamlessly like one. Because as soon as this is developed, it is happening here. So if there is no barrier, there is no delay, so why are we saying they are different? They are no longer different, just one. The DevOps person makes that. All right. So do you understand now that as a DevOps person, it's not out of place to mention agile in your job description? Agility?
It's not.
It's not clear. Oh, it's not out of place.
Yes.
All right.
Based on this explanation as well, it's like we need like basic knowledge of all these people we are working with that develop all those codes and stuff like that. Based on this explanation.
Yeah. So yes, you are there. It's called collaboration. You are collaborating with them. Anybody that you are interfacing with, you are collaborating. So as you should have at least a high overview of what the role of the developer is. Then as you delve into the role proper as a DevOps person, over 1, 2, 3 years, you should learn at least 1 or 2 tools that the developers use. Because on one hand, you are interacting with developers. On the other hand, you are interacting with operations. With operations, you have no problem because what you have been doing so far is more on the operation side. Your use of Linux, your ability to set up infrastructure in cloud, yeah, that is more of operation. Well, yes. So you find somebody who has been DevOps engineer for 7 years. He does not only know what you know, he's also talking about, I know Python, I know Java. And you're wondering, well, that's not, yes, just because of the observation you made now, by continuous interaction and collaboration with these people over the years, he now knows the tools that they use. And then even with operations, there are deeper levels of operations that you would come into. I mean, there are over 2,000 services in cloud. You barely know up to 30 right now. You know more and more. Yes. Yeah, good contribution. Any other contribution or explanation or your understanding of the concept that we explained? Yes, anybody? Okay.
So the main difference between the waterfall and agile is that agile is independent of each model. They're independent, but waterfall, they're dependent on each other.
Maybe you want to say that in agile methodology, the software are written in modules, but this module depends on this module to work, and they all join together like a chain. What I'm saying, what I meant by independent earlier on means that it does not mean that if you remove this module, the application will work the same. No, it just means that if the application has a problem, you can isolate the issue, resolve it, and bring that part instead of troubleshooting the whole application for where the issue is. But for waterfall, it is not. So this same application in waterfall will be one solid, one rigid application, not in modules like this, not in iteration. But yeah, that is one. The major difference. Any other difference between agile methodology and waterfall methodology of software development lifecycle? So the lifecycle is this concept of from idea to operations, all the things that happen in between. That's the software development lifecycle or application. But it's old school. It's old school. With this methodology now, we no longer follow this. we have introduced DevOps, and DevOps has now nullified this old concept of software development lifecycle. So instead of we're talking about agility and operations. In fact, technically, we don't even have business with agility. That's I mean, our technical responsibilities and focus as a DevOps engineer. This is for developers to worry about. Ours is give us the code and we'll push it into operation. So there is no need for business. Who is hiring business analysts? Yeah, maybe a few, but so this old method of business analysis, this one, no, it's no longer. DevOps is replacing that. So that is why instead of software development lifecycle waterfall, all you hear about these days is DevOps. This is more pro towards the new IT concept of machine learning and artificial intelligence. Yeah.
Yeah, so basically, the waterfall is just like, okay, let me speak to Agile first. The Agile it gives room for changes to occur during the the development phase of the application. So you can do in part, but in the waterfall, you just have to do everything before you even go to test.
That's right.
And then you put your products out in the market fast using Agile.
Yeah, you can deduce that last statement, not because it's obvious, but you are deducing from what you understand about delivery. Yeah, that's right. That's right. What will take you 15 years to build here before you release to the market? This one, 3 days, you already have something in the market, at least foundationally. And then you can keep building in that one. Maybe 3 days is exaggeration. 3 weeks, you already have something in the market. And then keep building on that until you get something. Wow. After 3 years of continuous. All right. Good contribution. Any other contribution?
I think I could also add that in Agile or in DevOps, we do set small goals in iterations. Waterfall, the goal or the end result is always towards the end of the entire process.
Okay.
But for, like in different, I could use my own experience at work. We'll have different quarters and then we have different sprints. And then we have different goals to achieve within those quarters and those 2 weeks of sprints.
Awesome. You're a Scrum person, right?
I learned Scrum, but I'm a DBS, I remember.
Okay.
But,
yeah, that's cool. Correct. So yeah. Still talking about the iterations. This one will last typically 2 weeks, like who was that? Like the last person said. And it is that 2 weeks iterations that that 2 weeks period, they call it the terms that Scrum people use for it. Yes, correct. Thank you for that. Any other contribution? What's the difference between Agile methodology and DevOps? DevOps also is a methodology. Yeah, all three are methodology. What's the difference?
Agile is the development stage, and DevOps is the combination of, or the transition or combination of development and operations.
All right, beautiful. So Agile affects only the development. Last time it's used. Correct. Any other thing you want to learn?
Yes, so I would say Agile basically manages the development of the application from the requirement stage to where the application is fully delivered, developed, demoed, and released. But DevOps basically uses the life cycle, the same life cycle, but it starts with the development to deployment using various tools and then includes maintenance.
Okay, yeah, okay. Another way of saying what, yeah, Another way of saying what the last person said. Correct. Good contribution. Good contribution. All right. So with that kind of contribution, when they are trying to intimidate you at interviews now, because these are not the real things anyway. The real thing for you is you're a technical person. The real thing for you is technical. But they may just want to see if you understand the big picture. And then because we are talking about collaboration, they want to see if you understand the work environment of the people you'll be collaborating with. Because essentially, as DevOps person, you are collaborating on one hand with developers and the other. So they want to. All right. So like we've already said, as far as operations is concerned, the only thing they may ask you here that you may not be ready will be security. But as far as using Linux commands and the tools and understanding how things flow from one, you know, have a problem. All right. So far, so good. Let's take it a step further. Maybe I should open the note now since we're following the notes. Okay. All right, let's look at the note. So a DevOps engineer is responsible. So yeah, we already explained. So can you see my notes?
Yes, sir.
Yes.
All right. So now that you know what DevOps engineers. So, so for DevOps engineer, are the steps roughly so, not rigidly, but for software development cycle, the steps will be roughly planning, requirement analysis or requirement gathering, design, implementation and coding, testing, deployment, maintenance. But it's not exactly, it looks very similar, not exactly like the last person pointed out, maybe consciously or not exactly like this. But in DevOps now, we have the planning stage. This is where the idea occurs that, okay, this is what I want to do. And then from planning, this is number one, and it goes that way. The coding is you are putting your plan you are converting your business plan to computer language that computer can use basically to software. I mean, you're already technical people. All right, so you code. Then like we already saw, at least you understand that part. After coding by the developer, you build the code. It is building of the code that converts the 180,000 lines of code into the app. And then the next thing you want to do is test the app, right? Okay, so you test the app. Once the app is tested and it's okay, the next thing you want to do is release that app to production. The release of that app to production is called deployment. And once it is released to your production server, or what we call operation earlier on, then it's available on the server and the whole world can access it and use it for the purpose. It's in operation. And then while the whole world is accessing it, or your specific customers are accessing it and using it for the purpose, they are getting the app and even the hardware resources, everything is being monitored. But the app at this level is no longer just the application, it's everything working together, being monitored. How much resources is it using? Where is the app failing? What should it not do that it's doing? How much RAM space? You know, all of these little details, as you will see later on when we look at some monitoring tools. All of these metrics, every metric you want, even in terms of who is attempting to log in, who is once they are logged in, who is visiting where, how many people are attempting to see things that they should do. Everything is monitored and logged to a file, to different files where you can see them. All right, so based on this monitoring, you're able to get feedback to know at least what to improve on the existing software and maybe what new features to bring to the application. So based on that, you now go back to planning. And then once you go to planning, the result of the brainstorming, the early morning Monday meetings of management and the executive directors meetings, all of that is part of planning. Everything is now converted to code to implement on the software, and then another build is made. So it keeps going like that. You see the infinity that I talked about? It keeps going. It's monitored. And then there must be something new. The minute you don't have anything new anymore, then in 3 years, 2 years, this business will go down. Will go down. There has to be something new. Google is not the same as it was 3 days ago. Every 5 minutes, Amazon, Google, and as a matter of fact, all of the FANG companies, they change something in code that results in new builds and ultimately change something in operation. It may be obvious and you see, it may not be so obvious, you may not see, but something is happening at a very high velocity every 5 minutes. So this is the workflow. This is architecture. So when the recruiter calls you to say, we saw your resume, we think you might be a good fit for this job, minimally, they'll expect you to have an understanding, a high-level understanding of this architecture, this DevOps architecture, from planning to coding to build to test, and then there is release of that app, and then this is where your infrastructure, the app is deployed in your infrastructure, your S3 bucket, your EC2, your whatever that infrastructure is, all right, your VPC. And once it's in your infrastructure, it becomes operational. The whole world can access. I mean, I'm assuming that you are designing for the whole world, all right? And then once it is operational, it's being monitored. There are monitoring tools like Nagios, Splunk, and in our own case, we are going to talk about Prometheus and Grafana. And then that will, from there, you can get feedback that you can use to plan the next line of action. All right. So at the plan stage, all you need is your Microsoft Word, your Microsoft Excel, generally you can put MS Office here, MS Office 360, if you must put a tool there. To code, we are viewing all of this from the DevOps engineer's perspective. So to code the tool that the DevOps engineer needs to interact with and manage, and basically to interact with the codes that have been pushed from developers is one of these three, one or more of these three. You could use the tool called Confluence, Jira. Jira is getting popular, but the most popular, of course, is JIT. So in this course, we are going to learn how to use JIT to accomplish this phase of the DevOps lifecycle or DevOps JIT. This is the tool, because we kept talking about tool. And then when we move from coding to building, it's now time. Now we have received the codes from developers. We now want to build it. There are many tools that can possibly use. But the most popular of them, or the one specifically for Java related codes, is Maven. So we are going to use Java codes, and therefore we'll be using Maven to build the codes here. And we'll build the codes, it will give us an application. That application, we are going to use Selenium as the tool to test the application. JUnit is also popular, but the ones that I'm picking, like I already mentioned to you, it's not just me that is picking them. The industry best and most popular. So that's why we're using them. And then once the code is tested and it's okay, we're going to release the app to our infrastructure that is set up in cloud, which you already know to do. And that is where Jenkins comes in. And it's deliberately put in the middle between this whole area is development and this whole area is operations. So Jenkins is deliberately put in the middle to interface between dev and ops, DevOps, development operations. All right, so I've had that interview question where they expect you to know that this part is development and this part is operation. So they may ask questions about at what stage does the development of this application end?
Are you on a different screen, sir?
Are you seeing my Word document?
No.
Yeah, we see the diagram. Is that what you're pointing to?
No.
Yes.
Yeah.
Oh, okay.
This one.
Oh,
this
okay.
diagram.
Oh, now I cannot
Oh,
see.
okay, we didn't see your mouse. Yeah.
Yeah.
Oh, okay. I was using. Okay, let me use the mouse. I was using my pen. All right. Well, you've been seeing this diagram on and on, right?
Yes.
Yes, we are seeing it now.
Okay. All right. So I was talking about. I was pointing here, and I was saying that Jenkins was deliberately placed in between here, which is the development part of this DevOps, and here, which is the operations part of this DevOps. And that you should know that of this 1, 2, 3, 4, 5, 6, 7, 8 stages of the DevOps architecture, this planning, coding, building, and test belong to the development stage, while the deployment, the operations, and the monitoring stages belong to the operations stage. It's really, Jenkins does not really belong to any of them, to be honest. Jenkins is just the integration tool between them, like we will see. All right, so we're going to learn Jenkins as the integration tool. And then for what's the next thing? Deployment. For deployment, we are going to, of course, we already know, we're already doing that in AWS. We know how to set up servers and push our codes to server. But on top of that, we are going to do it at the container level, no longer on bare servers. We are going to learn how to use Docker as a tool to create containers and deploy our app to containers instead of just server. And then we are going to, for operations, we are going to use the tool Ansible to automate the deployment of that app into the containers that will go live for the whole world to see. And then once the whole world is seeing it, ideally our work should stop there. We should say, hooray. And then, but no, it doesn't stop there. Need to continuously monitor how the app is performing, how the market is responding, what is doing well, what is not. So would install monitoring tools. Like I said, nothing is hidden from monitoring tools. It will monitor everything. Whatever is coming in, going out, where they go, what they do, where everything is monitored. Just like CloudWatch does in AWS. But while CloudWatch does that for the whole of AWS, we are going to plant specific, monitoring tools that will specifically look at the containers that we have here, the deployment that we made here. This monitoring tool to focus on them instead of on all of our AWS more specific. All right. So for that monitoring tool, we are not learning any of this. We are learning the one that is related to containers, and that is permissions. All right. So these are the tools that we are going to learn in this. And of course, there are some more that are not mentioned here. So that is what we mean by here. So here we are going to learn for continuous versioning. We are going to learn Git and GitHub, Maven, Jenkins, and so on and so forth. All right. And then here we just try to explain the waterfall model. Not really explain. We mentioned them here, but we'll explain them. And then we said that Agile is relevant only to the development stage, like you already saw. And then we now say, once Agile is ready, the codes are put to operation. That is the concept of DevOps. All right. And this is just another way of without the tools this time. This diagram here, this is another representation of it. Here, where Jenkins is occupying its true place now, integrating between development and operations. So you see that it does not belong anywhere, it's just in the middle. And then if you see, it's still maintaining the infinity symbol. All right. So in the development stage, the part, well, that may not be so obvious, but you see it later. The planning and the coding part of the development stage is called continuous development. The building and the testing part is called continuous testing. So that's what we'll get, this continuous build, continuous integration, all these components. And then the Jenkins as a tool will do the integration between the development and this other part. And they will have continuous deployment and continuous monitoring. Everything is continuous, nothing stops. And that is the concept of DevOps. DevOps simply means continuous, nothing stops. Continuous improvement, continuous code change resulting in continuous deployment, resulting in something new in operation. All right. So like I said, at interviews, you're expected to understand, have a high level understanding of this DevOps methodology. All of the diagrams are just emphasized. We could have just done one, but I'm just trying to emphasize that you must understand this diagram enough to be able to explain. This is what gives you the first round of interview. They are not asking you, what do you do here? No. Just an overview, a high level understanding of this. That is what gives you the interview. Even if you don't mention it, yeah, if the person is knowledgeable, or depending on the sample question that they give to the recruiter, he might ask you, okay, in your build, what tool do you use? What tool have you used before in your build? Maybe, oh, beautiful, yeah. Have you used Docker in container? And when you deploy, they just ask you questions around it, but not at a deep level. Just, yeah. All right, and for that reason, I'm giving you one more diagram, just so you really understand what happens in planning, what happens in coding, which we already explained, what happens, summary, we really summarize, in builds, that all of the happenings within these 3 stages are generally called continuous integration. Again, at this time, it's just English, but when you come back to it later on. And then once it is tested, and then it is released to production, then you now have continuous integration. In operations, you are not really doing anything. It's the customer that is using, the end users that is using it. And you can only tell, the only way to tell what is happening in operations is to monitor what is happening and be able to read the log files to interpret things. All right. So this is where we got the terms continuous integration, continuous delivery, continuous deployment. All right. So this is your notes. I'm going to give you this. And then, of course, I also try to explain the meaning of continuous integration, continuous deployment, and continuous delivery. All right. This is a good one to explain. Any question at this stage? All right, let me just explain this now. All right, so you remember what we defined as DevOps earlier on? That there are 2 parts, the application development and operations. Can you see my pen this time? Okay, let me still use my mouth. In DevOps, the 2 parts of application deployment, development, and developer, and operations are meshed together to form DevOps. You see that? And then you see this. Everything is DevOps. I've already saw. We're just emphasizing the same thing, saying it over and over because you need this to get it. So there's the plan stage, there's the coding, there's the create, there is test, release, deploy, open. All right. So the whole thing is DevOps. But what if it stops here at deploy? That is called continuous deployment. What if it stops here? It starts from planning, code, create, test, and it is released. What do you call up to the stage of release. What do you call it? It's called continuous delivery. What is the difference between continuous delivery and continuous deployment? You can help. You can help, so I take a break from talking. But what you see now, what's the difference? Hello, anyone there?
Deployment.
Hmm. So the diagram shows continuous delivery, and it also shows continuous deployment. What's the difference? What do you see?
Continuous deployment is the means of deploying the application, while continuous delivery is the hello?
Yeah, we lost you. We
I
lost
said
you for
continuous. I'm sorry, I'm outside. I said continuous deployment is the act of deploying the application, while continuous delivery is the act of managing the application, upgrading, as in versioning the application.
managing the application.
Managing the application, upgrading, as in versioning the application.
Okay, not quite so. Any other attempt?
I want to say continuous delivery is kind of that is where the changes to whatever we are developing is effect and tested, like continuous delivery. Then the continuous deployment is kind of a focus on the actual deployment.
Okay. So, do you remember what deployment is?
Yeah.
Okay, so let's go up. Deployment. So, deployment here. Okay. That was not okay. Let me explain that. Maybe.
Can I try?
Okay. Yes.
So continuous deployment is at the point I might be wrong now. It's at the point where you've tested, you've verified, and you're ready to release the pipeline for production. Delivery is right after test, and you are at that point where you are possibly contemplating either to release or to pull it back for.
Okay. All right.
Can I
mean,
attempt, sir?
Yeah. At least I see your attempt.
So,
well done, at least on the try. Yeah.
So basically, for the delivery is all the activities between the planning and the release, and then but the deployment is when you actually engage the new release and you put it into production. And then of course you are able to get feedbacks and all of that for the next release again. So deployment is basically the movement of all of the things you have done in the last iteration, based on the feedback from users and the staff and everything, to get something new and move it into the development, and then from development to operation to production. That's been that's for the deployment. So it is deployed when it is in production.
Okay, that's good. Very good and very clear. What about what's the difference between that now and continuous delivery? I mean, the deployment part is very clear, I understand that, but I don't understand what delivery is. Continuous delivery, what's the difference? Okay, let me not stress you. So, but yeah, I mean, that was good. I've explained that difference. All right. So for the rest of us, so what is said is, if you can still see this. So first of all, All of these steps are automated. Automated by you as the DevOps engineer using the tools that we highlighted earlier on. At the planning stage, I use my Word document, my Microsoft Word to type, maybe my Microsoft Excel to do some analysis, maybe my CorelDRAW to. So whatever application I'm using here is purely non-technical. I mean, even if I don't have computer skill to do any of that, at least I can call somebody and say, write it. So we're not really doing anything major. At the stage where it occurred, the idea occurred to be anything major technically. But for coding, yes, I'm doing something major technically. I'm using the JIT tool to pull the codes and manage the codes and a lot of commands, JIT, and so on and so forth, like already explained. Now, first of all of these steps is automated in a sequence of steps that somebody called pipeline earlier on. I'll reserve that word for later. Yeah, but for now, let's just mention it to explain it. So all of this will form a pipeline. This connecting to this, so that once this completes its work, it should flow to this. And then once this completes its work, it should flow to this until it is deployed to this production server, like that well-explained concept told us earlier on. So when the automation of the pipeline is such that anything that happens is actually called when there is a push in code, when there is a change in code, or better still, when there is a commit. All of that terminology simply means when a code changes. When a coder, a developer somewhere changes a code, it should not just be redundant, it should go all the way. It should trigger a series of actions that would run through the pipeline to deploy to production server. In other words, when I change the color of my website, if a coder change the color of which website is this? Maybe I'm working for Google or maybe Amazon. All right, so maybe I'm working for this company. And then, and they say, we don't want this color to be blue anymore. We want this color to be red. I mean, this is not just a simple website. This is actually an application. You may not understand, but it's an application. All right. So maybe we don't want this color to be blue anymore. Our corporate color has changed to red. So we want to change this to red. So we're going to tell our development department that change this to red. So the person that eventually gets that job, that task, the way to change it to red is to look for the code that made this one blue, and change that code from blue, whatever the code color for blue is. He will look for it and change it to red. He would have changed that code on his own laptop. Now he would, he would commit it to the central repo. But the point I'm just making is, where's that data? Haven't made that change in code, that change should reflect in production. I should see it as 1 minute, this is blue, the next minute is red. Not because anybody did anything other than the code being changed. That is automation we're talking about. You're changing the code by the coder in Afghanistan, changes this blue to red. All right. So that is this experience, what you see as changing from blue to red, is what I'm trying to explain here as changing code here, if you can see my mouse, resulting in changes in deployment. So that automation that allows changes in code to result in changing in deployment is called continuous deployment. You have already automated the pipeline, the CI/CD pipeline. that anytime something changes here, let that effect be felt in operations. I mean, whatever changes in deployment, like the last person said, automatically changes in operation. Operation is just the view of the deployment by customers. Now, what about continuous delivery? Continuous delivery is saying, do not push that change from, do not, a change in code, a commit, a change in code is called commit. A change in code should not result to automatic change in deployment. I should not see that red call automatically. It should stop after release. It should stop at release and wait for manual trigger by a manager, a supervisor, the CTO to click something manually before it now releases to deployment. In other words, the automation stops here. It does not automatically automate to production server. It stops here, like you will see towards the end of when we start to deploy production server in Jenkins. In some cases, we will need to click a button to say, yes, release, approved for release, before it is now deployed to production. All right. So the difference is continuous delivery will wait for final approval, manual approval for deployment to production, whereas continuous deployment would automate the whole process and it will be deployed to production automatically without any wait.
Mr. Yes. Can I say something?
Yes, please.
You explain it the best. What you just said makes sense now, because I just want to share this experience. At work, in a dev environment, they will allow it to go all the way to deploy. But for production, I now remember that they always need an approval and let it stop at delivery. Now it makes sense.
All right. Awesome. So all the pieces are adding up. Good.
Yeah. So when you pushed it for release, you could see your release actually take effect. But when you push for release in other environments, it will stop and need somebody to approve it.
Exactly. That's the actual operation. So for my own app now, we're going to have the production environment that only me can control. And then we're going to have maybe one or two more environments. We can call one dev environment for developers. Whatever they need to do, let them do it in that environment. Let me see it work and approve it before I now say, oh, I like what I'm seeing. I'll now click release to go into production. And call another one testing environment. They'll hire some Nigerian guy to say, okay, whatever the dev people are doing, you also test it and make sure I cannot be there testing everything. They'll push to you, or if they will deploy in test environment. You test, check everything. And once you have manually tested everything and everything is working accordingly, then you let me know. I'll go straight back to that code that you tested, run it, and now release it to my product. So those are the multi-environments that you can have, because you don't want to make mistake of a nude picture, for example, going to production without the supervisor, first of all, seeing it in a test environment and confirming that everything is good before releasing the production environment. Awesome, good experience. All right. So the rest of you, do you have it? You understand how that works? Then? So you see the difference between the continuous deployment and continuous delivery. All right, I assume you got that. What about continuous integration? Continuous integration, like we may have seen earlier, is just the part of software development, coding. I mean, it's the part of software development. Now, there was another interview where you see this, yes, you see this test step standing in between development and operations. Where do you count it? It's hard. So this is up to the company. What company was that? I think it was no, it wasn't a major company. But it was just one interview, one tech interview, one stage interview to get the job. Of course, I was going to the interview for the experience, you know what to bring to the interview. Anyway, so even though the test is neutral here, does not belong here nor there, it usually, that guy was saying, in their company, the test here is part of development. So you do not mark the development as complete. They've done their own part until the test has been done and completed. Like we saw that somewhere else. Yes, this test is part of, you know, there are only two parts, development and operations. So as long as test is on the development, yeah, this is ideal. But it's not rigid. All of these are just for you to have a picture of what these things look like. No, it's the company decides that, well, testing, we want to bring it, it's up to them. But I'm just sharing this experience because I had that experience at, you know, in many interviews where this man was actually, because my interviews are more like interactions. We are just sitting down, we are discussing. It's not like anything serious. How do you do this in your company? Oh, yeah, test. Many companies do that like this, many do that, but in our company, this is what we do. Oh, you're coming from a background where it is not like, oh, no problem, I understand that, but it's slightly different. No, you just interact. So test is generally counted, or maybe safe. I don't know how to put it, but I would prefer to count this test as part of the development part. Hence the dialogue. So when it gets to the level of test, we call all of that development. And continuous integration simply means the development part of the DevOps project. Okay, what about Agile? Agile will stop here. Agile development, all right? The coding, and what is after coding? The build. Every time there is a change in code, the build is automatically done. Every time there's a change in code, a new app version, a new version of app is automatically released. Anytime there's a change in code and a different version, in other words, the app changes. Even if it's just a dot that you added, it has changed the different version, right? And all the versions are saved, they are not destroyed. The old version is not destroyed. You just save separately with a different name, maybe version 1.1112, then the new one will be version 1.1113. And then because you have them all saved, it is called version control. Version control. The old versions are not replaced. All right. So you understand this, then right now you can put up your resume, and then at least you know that you stay through the screening stage of, okay, we understand that you're a DevOps engineer. Okay, can you give me a quick overview of what you have done? Yeah, I have done this, I have set up this, I have done this. Right. Okay, and then finally, yet one more diagram just to reiterate and make sure that you understand what we mean. And then the last contribution that we had of the man who had the experience, this is what he was trying to explain, that in build you could have and this is what I meant when I said I could have a test environment, a development environment, and ultimately my production environment, right? So my developers would work, and then they say, yeah, the stuff is ready. I push it to my test environment, and the Nigerian test guy tests everything and says, no, there's something wrong. Go. Then I'll go back to my developers and say, no, there's something. When I go back to my developers, it means that I'm going all the way back from this test back to coding. My plan is already my plan. I'm not changing my plan. I already know what I want. So it will not be released into production. They'll go back to coding to change whatever I'm complaining about. This is not what I want. And that's what we're going through right now. This is not what I want. Can you do it like this? Do it? Yeah. And then a new code, a new app is due. We'll test again. No, it didn't pass. I don't want that. This is what I want. Oh, it just keeps circling here. Then someday they get it right, it passes. I say yes. And then we now move it, we release it. In that case, not necessarily to production right away. Want to push it to a staging environment, maybe like development or testing or whatever name you call it. It's just saying that it doesn't go into a place where the whole world can see it right away. It needs to pass through one or two stages, usually development, testing, before you now deploy to production, where the whole world, where all of the customers are being used. That production server is sometimes called QA server, instead of production called QA, right? So yeah, the same thing that yes, that continuous integration delivery. We should know the place of development. Of course, we are going to start using Git. I don't know why just almost right away, so we'll see how that works. All right, questions? That was a long talk, but it was necessary to understand the concept. Anybody here?
Yes, we're here.
Yep, we are here.
All right, so make contributions.
Maybe it's a question, sir. I know you mentioned a central repo in this process of building code to release. At what point does it go from the developer's local computer to the centralized place for the team to see?
I'll show you now. That's the next thing you want to do.
Okay.
So the next thing you want to do now, if there are no questions, is to go to, for me to show you that central server, that central place. So you are going to create your own central place account so that you have a direct feel of how it will go. And then, yeah, let's go there. So what's the first you want to learn? Git. But to learn Git, let's first of all, exactly the question that was asked now. Let's first of all have a central place where our codes will converge. All right, so let's go to setup one with GitHub. Create your version control system in GitHub this time. Last time I delivered this class, we used Bitbucket. But let me change that. So these are some of the changes I've been making. So GitHub. Actually do. All right. Are we ready for practicals?
Yes, sir.
Oh, should we keep practical till tomorrow, till next time?
No, always ready.
Okay, I want us to see whether you asleep. All right. So let's go to GitHub. This is the path. Since we cannot copy, let's go to Google. And then we'll go github.com. Let's create the account together. Everybody go to GitHub if you have the system in front of you. And then create your GitHub account. So this is the central repository. By the way, have I explained what, do you all understand what central repository means? Do you understand what it means?
No,
Anybody?
sir, I don't understand. No.
Okay, let me quickly explain that. Let's go back to this drive. So, like the last person asked, now, so we said Tesla has how many developers? 3,000, right? In actual fact, I'm sure there'll be more than that, but let's just see. So they are working from their laptops, right? From different parts of the world. This is their laptop. Nigeria, Uruguay, Paraguay, and so on and so forth. So this guy is writing codes on his laptop, codes 9 to 50. This guy, his own task is write codes 51 to 100. This guy, 101 to, and so on. So they are all writing codes for Tesla, right? So what about the codes that programmer 1, programmer 2, programmer 3, programmer 4? What about the codes that they are writing? How do we make all of the codes available? Would have a central place in cloud. Let me just patiently explain. We'll have a central place in cloud that all of them will connect to, of course, over the internet. Right? So that whatever code they are writing on their own, they can push the code into this central place called version control system. That's the general name for such a central place. Specifically, the tool, the cloud server that we are using for our version control system now is GitHub. It's about the most popular. All right. So what does it do? It simply means that this is the place that when they finish writing code, they will push to. So this is also the place that you, as the developer, you are connected to. And you can now pull all the codes from there into your own system. So this is your system as the DevOps guy. So I want to show you now how to set up this place so that these guys can push their codes to the VCS and how you can pull all of those codes from this central repository into your own local repository. This is called repository, general repository repo. So this guy has the codes locally on his system. So this is local repo. This is local repo. This is local repo. But I cannot access 3,000 unique systems just to draw codes. So everybody would push their code to the central repo. And together, the central repo working with their local repo will form what we call distributed repo. Distributed. You read all of that up in theory. There's no need to waste. All right. So, okay, let me label this. So this is central repo and distributed repo. Distributed just means distributed. Means that in the case that the central repo goes down, we can always set up a new central repo. And because these guys still have their repos in their local machines, we can always push back there to form a new one. And in any case, these guys are always working on their local machine. Even if this goes down, it does not affect their work because they have a copy of the real work on their local machine, working all day before they push to the central repo at the end of the day. So the term distributed, instead of just saying central, means that we have a copy of the repo here and a copy of the repo here, so that in the event that one of them goes down, it's able to retrieve from the other, and the same for each of them. A copy here, a copy here. So it's distributed across the entire repo network. Did you get that? Yeah, the person for whose sake we came here to explain. Did you get that?
Yes, sir.
All right. So as the DevOps engineer for this project, where are you pulling the codes from?
From the central repo.
All right. What is the name of the central repo that we are using for this project? What is the app?
GitHub.
Oh, GitHub.
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 GitHub. GitHub. Central repo through version control system is the same thing. All right. So the developers writing parts of this code from all over the world, they are first of all writing on their local repo. The local repo is called JIT. Where's my pen? It's called JIT. Right? And then the central repo is JIT. And then they now use JIT commands to communicate, first of all, to manage the local repo, and also, no, they use JIT to manage the local repo, and they use JIT commands to communicate between the local repo and the central repo. All right. So my question now is, question one, where do developers push their codes to?
GitHub.
Version control system.
Yeah, GitHub specifically in our own case, but generally they push it to version control system or some central repo, like you already answered. All right, good. Where, okay, you already answered that the DevOps guy pulls the code. When the DevOps guy pulls the code from the central repo, what does he intend to do with the code that he pulls from central repo?
To make changes and deploy it?
No.
Distribute it?
No.
Runs it?
Run. They are just codes. They cannot be run yet.
So is it okay to say to
He wants to
analyze
build
it?
it.
Build
Build it.
Build. They build the code, build. And when they build all of these 3,000 or 30,000, 130,000 lines of code, when they build it, what comes out from that build?
An application.
The app, correct. So this is the app that we're interested in. This is what we'll be using for now. Awesome. All right, thank you for bringing us here. So we have learned what. So can we now go and set up a version control system using GitHub? Any other question here? Okay, of course.
Sorry, so can we take 5 minutes break?
All right, that's good. Even me, I need 10 minutes break. So this is 7:40. Is 10 minutes okay? Yeah, let's do. Is 10 minutes okay? Do you want more?
Yeah. Or maybe
10 is okay.
When does the class end?
3 hours. We are doing 3 hours.
Oh, okay.
Okay, let's do 10 minutes. So let's come back at 7:50. All right, guys. See you then. All right, guys, we are back. Are you here? Are you here?
Yeah, I'm here.
All right. All right. So we're trying to open up our virtual control VCS. I confuse that a lot with VSC, so I'm just careful. All right, with VCS using the GitHub. So log into GitHub using this URL, github.com. So we can create accounts. Okay, so you click sign up. And you've created an account many times, so it shouldn't be a problem creating this one. So enter your email address. Is anyone following? Is anybody sitting on their system to follow?
Yes, we're following.
Yes, sir. All right, please go ahead and set up your GitHub account and the rest of it. Let me know once you are done creating an account. Everything moving smoothly yet? Excuse.
So should we choose just me, student, as a student?
What are the options?
Just me, 2 to 5, 5 to 10. Are you a student or a teacher?
Just means two to okay, students should be fine.
Okay.
Just me. No. Students means you are in a higher institution like university. Did you say just me? I've forgotten that string.
Yeah, just me, 2 to 5, 5 to 10 members, 10 to 20, 20 to 50.
Try just me.
Okay.
You are not a student unless you are logging on from a university URL or you have a university email. Yes.
And it will say just me, are you a student or a teacher?
So who has gone past that stage? Please help. What did you tell there? Well, I already have an account. So.
I think you can skip that part. Let's see.
There should be a skip. I didn't see that.
Okay.
I just selected the student. Let me see what it says. Set specific features. So everything.
Okay, so I went back. I back twice. and I put my code again and it didn't give me the question again.
Okay.
Mm,
Let's go.
So should we select everything for the features?
I can't see where you are. Who understands that question?
It said the tools you need to build what you want.
No, you don't know the tools yet. If you can skip there, just
Now,
or
on the
what to what,
side, it said collaborative coding, automation and CI/CD, security, enterprise security.
just select as many as you want to. But,
Okay.
collaboration, coding,
You
CI/CD,
didn't give me that
yes.
option.
But it's
I
not really
don't-
a serious thing.
I don't have that option.
No problem.
Okay.
Just go with what you have. Has anyone successfully created an account?
Okay, so I select the one that says continue for free.
Yeah. So what did you take before?
Because when I selected the student, he gave me apply student benefit, but I skipped that one to seek continue
I
for
didn't know it would be
free.
so difficult. I thought because we have gone this far, we already know.
Okay,
I
so
would have just taken
yeah,
screenshots.
okay.
Yeah, continue for free, of course.
And
Definitely.
then it said the home for all developers, including you, that creates on the left side, it said create your first
You know what?
project.
Just pretend I'm not here. At this level, you are DevOps engineer already. I mean, you are automation engineer. Pretend I'm not here. Do the best you would if you didn't have me to ask.
What I do is I skip
look
all those
around.
configurations I was able to create it on my pad.
Because you
I
don't really
just
know them
skipped
at
all
this
of it.
stage. Yeah. Look around, pick the best options there. At this stage, after, yeah. That's not the hard way. Even if you make mistakes, you can always go back to those. Anyone successfully created the account here?
Yes,
I
sir.
already had an account before. Yeah.
Okay, you had an account. So anybody created a new one now successfully?
I did, and I'm on the page that says the home for all developers.
Okay, so go down and do the one that says, I think it just says continue. After read me, that says hi, whatever your username is.
Okay. You see that?
Okay.
And
All right.
copy
Everyone
the
on the same.
readme file, the new edit file, that, and then say, I'm not sure, attached by dragging, dropping, and then
All right. So have you signed in after you successfully created the account? Can you see my screen? Did you come to this stage where they asked you to sign into GitHub and you provided your username and password?
No.
Yeah.
Well, I'm in.
so copy your readme and paste it in the new file, and then
No.
No.
Just tell me when you get to the level where I can take you guys. All of that is not necessary.
If you
Did
are
anybody
in
get
and
to
you
this
log
level
out, if
where
you are in and you log out, you will see this.
can you log out now and see if you can
Okay.
log back in? If you still cannot, that means I have to create a fresh account so that we'll do it together. I'm not happy that you're not able to do this simple thing by yourself.
Okay,
How do you want to be a
so,
DevOps engineer?
okay, sign out, sign in. Okay. Okay, I'm in.
Okay, one down. How many to go? Let's get 2 more people to sign in successfully.
Amen.
I'm
I'm
in, but it took me to
Cool.
the home up for all developers.
Don't worry. Are you in? That's just what I want to hear.
Yes, yes.
You don't even know where you ought to be, so don't worry about it.
Okay.
All right, username, password. Let's sign in now. We're gonna... All right.
Okay, yes.
So it brings you here now.
Mm-hmm.
Oh, beautiful. So this is the next thing. Let's go to the notes. We are going to set up our password. But about 2 years ago, in fact, they changed the password format. So you are going to go to settings and then developer settings and go to personal access token. So this is what I mean. So come here and go to, come here, click settings here. All right, go to your avatar, settings, you see your profile, repository, go to settings, and then come here and take settings, password. Let's look at that person.
Developer settings.
Developer settings. All right, so go down and look for developer settings. Can you see it? The bottom here. You cannot see, so click developer settings. All right. Now click personal access token. Personal access token. And then say, I already have a token, so I'm not generating anymore. In your case, say generate new token, and then copy it and save it. A safe place. So this is your password. This is the token with which you sign into your sign in and connect your JIT to your GitHub. This token.
Okay.
So when you said,
Okay, so something happened when I clicked the token, generate token, it did not generate.
Mine too didn't generate.
you clicked generate token.
It's going to generate. You see it's going to bring the note. Then you scroll to the bottom if you don't want to. The note is just like a tag. Then you go to the bottom of that screen. You will see generate.
Okay, let's take it from
button.
here. Are you seeing a similar screen here that I'm showing you here? Are you seeing
so
yes.
What you are seeing? Is it similar to this?
Okay.
At
And
the
then
top.
what did you write? Like the notes was, I mean, if you write anything in the note?
Yeah.
You're not even answering my question. Can we have a one class, please? Can you focus on this? What are you seeing on your screen? Is it similar to what you have here right now?
So we see that. So when you click on
hold on. I just need you to see everybody to be here so that we'll do it together. Is there anyone who is not here, who is not seeing what I'm seeing? If you're all seeing that, so let's click it now and see what problem you're having.
Yeah.
Note, what is this token for? I'm sorry, I don't want to be, but it's obvious now. What is this token for? Write it there now. Write something there. You are not babies anymore. I will not talk to you like I'm talking to you 1 month. You already developed class solutions architect. Write something there. Is it for class practice? Is it for my personal practice? Just anything. My practice or something. Or number 1, or my token. Just anything. What is this token for? That's what it's asking you. When does it expire? Don't even bother about all of that. The next thing I expected you to do is go all the way down and say generate token. However, since we are here now, I might as well say, well, it doesn't expire if I want. But it's a good practice to have it expiring every 30 days so that you are forced to change it. Because your password, you don't want it to be permanent so that people who withdraw. All right. For me, I'll just say, with this token, I should be able to do all things. I mean, just okay, it's your personal token. I should be able to delete packages, whatever you want to be able to do. We are not giving it to anybody. So you want to select all of this. Not, you don't have to, but I'm just saying, since we are here, I can just show you. I have the authority. You should give me the permission to delete repos, to do whatever. Some of these things you don't even know what they mean. But once you can just pick the ones you know, but since I want to be able to do all things, I may as well pick even the ones that I don't know. All right. Whatever you want to select, select. If you don't feel like selecting anyone, what we really want to be able to do is use JIT. So I think it's better to select all of them. But you don't say, I'm not able to do this because you did not select. And then once all of that is done, you now click generate token. I'm using that. I've used that token in several places. If I click generate token, I'll have to replace my own. I'm trying not to do that. To generate token, it should generate some long password. Copy that password, that token, and then open your notepad and paste control, whatever it is. My own token, look at my own token that I generated. Look at it. I saved it here in my. So yours should look something like this. You copy it. In my own case, I have a note for you. So I save it there. So you don't have a note, so you may want to save it. I will save like that. And save it as my token. I actually saved mine too. Or whatever name you want to call. All right. So you are ready to go now. Now you have created a central repo, GitHub, and now you have your token set. All right. So that is it. The console. All right. So that is it. We are done with GitHub. You've created the central repository, and then you can access it. Now let's go and access it. So we are done here. Let's go to our VS Code. So remember our VS Code, it is from here that we want to connect with everything we do from now on. All of the tools, the GitHub, Jenkins, everything we want to connect from here. This is our integrated. It means it's integrating Git, integrating Java, it's integrating everything. This is the environment from where we work, integrating all of the tools, the ones we know now and the ones we will know in future. Everything's integrated. All right, so come here. And then as usual, you want to open a new folder. In my own case, what's this course? DevOps. Let me create a new folder and call it, let me call it, all right, so I take this working folder and I say, I want to work on that concept. We're already used to that, but I can't find my terminal. So I create a new terminal, and I'm not working with PowerShell, I'm working with Ubuntu. No, Ubuntu 20 and so forth. All right, that is it. If everyone here is here, fine, we'll go on. If you are not all here, tell us where you are so that I'll pick you and bring you here. Everyone here?
Yes, sir.
Awesome. Who is not here?
I'm not there yet. Let me see. Ubuntu.
Yeah, Ubuntu. So we want to start learning JIT now. JIT command. JIT command, the first tool, JIT. A lot of, well, if you could learn Linux, then there's nothing to do. We've added, before I used to teach like 15, 20 commands under JIT, but now we're going to do a lot of work on that. Okay, expanded the curriculum. All right, are we ready? Are we here? Did you create your work folder? You gave it a good name, and then you see that the same name is showing here as you have the. This is the real deal.
I'm actually lost right now because I just opened my computer now. I'm just back. Please, I don't know. You just have to kind of make the video available very quickly so that I can.
Yeah, the video would always be available, sure. If you cannot follow, yeah, it's understandable, no problem.
All right, thank you.
Yeah, definitely, I know. Some of you will be busy with other stuff. Once I have one or two persons,
We're there.
okay. All right, so now let's go. What's the first thing we want to do? The first thing I want to show you ever is how to clone a repository. In other words, a repository that's already available in this central repo in GitHub. How do you make a copy of it into your own local repository? That's the first thing I want to show you. So for this particular project, what's that? I hope that did not disturb. So for this particular project, I have a code for you. I have a code for you. So this DevOps that we want to, these DevOps projects, the codes have been written in Java by some developers. You know, it's not your work to write codes. You know that by now. Developers write code and they push the code to your repo, your central repo, your VS code, your version control system. All right, so this is the code that has been written by developer and pushed to your GitHub. So you have it now. How do you now make a copy of this onto your own local system here, like we said that from GitHub? This is how to do it. Very simple. So I have this. You are going to do it because this is publicly available to you all. This is where it will be. Yeah. So take this URL. What do I put it? Control C. What do I put it for you? I'm not. So can you copy that?
Maybe we put it on the chat.
Yeah, the chat is not on my laptop. Let me just wait for you to copy. So go to github.com and then type theITern /DevOps-projects / and you should be able to access it because it's publicly available. You can actually do the ITern. Don't worry about the last part. Just put the ITern in front of github.com. You see what I'm saying?
Yes.
You saw it?
Yes.
Awesome. So click DevOps project codes. This code is in Java. This is the code we're going to use to build our application in Java. Oh, we're not building the app yet. I'm just showing you how to download it. It's called cloning, how to clone it. so that you have a copy of it that you are going to convert to app. So click the repository. So are you here now?
No, mine is kind of different. I mean, it shows the first part, but it doesn't show everything. Repository. ITern doesn't have any public repository yet.
No,
Did you type the icon?
just type theITern. It's going to bring you to the page on the screen now. After the github.com/theITern, you will see this screen right from your GitHub environment.
Okay. Okay, yeah, I think, I see. Okay.
Okay, so click the DevOps project.
Yeah.
Now come to code. And then you see clone. That's what we're going to do. We're going to clone. So copy, just click copy here. Click that. That's it. You are done. Have you copied?
Where it says clone? Yeah.
All right. You haven't clicked copy here and you have copied. Go to your VS Code. You know you prepared this one earlier on. The first, The first thing you want to do here, sorry, I should have to start with it. Of course, anytime you have your VS Code, your Ubuntu machine, what's the first thing you want to do? Remember? You want to do
update.
Sudo app update. Okay, but we are root, so I can simply do without sudo, I can do app update. All right, it's a good practice. So I'm updating now. It's done. I may also want to upgrade. Sudo app upgrade. Awesome. Do you want to continue? Yes. Good practice. All right, so I've updated and I've upgraded. Clear. Do I have JIT already installed? If not, I want to install JIT now. To install JIT is easy. It's sudo yum update, in this case, Ubuntu. You'll be sudo apt install JIT. That's the command to install. You already know how to install command form. Thank God we have a good understanding of him. But before we even install JIT, let's see if it's already installed. How do you check if the service is already installed?
On the RPM.
It's always the name of the service minus version.
Oh.
Always. All right. So what does this tell us?
It's telling us the version that you have, Git version 2.34.1.
Correct. So JIT is already installed, so there's no need to install.
Okay, I have the same version. Yep.
Yeah, it doesn't have to be the same, but as long as JIT is installed, you are good. All right. So now that JIT is installed, we can now use JIT command. I mean, it was already installed with Ubuntu. Ubuntu is actually more robust, more packaged food. With Linux, you may have to manually install. It may not come naturally, by default. Okay. So now, I hope I'm slow enough. Everybody's catching up. Did you leave anybody behind?
No, we're good.
Okay. All right. So the next thing I want to do now is start to use JIT. Now, I want to do JIT init. It means create my local repository. Initialize my local JIT repository right here where I am. That's the mean. JIT init. Remember Terraform init? The same thing. All right. All right. What does this say? Initialized empty JIT repository. So JIT is now available. I mean, my local JIT repository is now available. If I do ls -l, I'm not saying anything. But if I do ls minus LA, you now understand why I got used to ls minus LA, because it will show me all the content, including the hidden one. And I see that JIT is there. All right. So that's the first step. It's already in your notes, everything I'm doing here. So the next thing I want to do now is clone that repository so that I have a copy, because there's nothing inside here right now. So that I have a copy in here. The command to do that is git clone. That is the command. And then what I copied there, I just put it right there. Remember what we copied when we went there? Git clone that repository. So have you typed your own command? Git clone, then copy that. You press enter, and it is cloning. It's cloning. Making a copy of that web-based repository, that cloud-based repository in Git onto local repository, and it is done. And you can see it showing here automatically. All the files that my developers pushed to GitHub here, I have made a copy, I've cloned it, and I now have a copy in my local repository. That not awesome? If we now do ls minus L, we're going to see that we have. So did you understand that so far?
Yeah. So
fact,
how much time are you going to take to finish this?
Sorry?
Oh, it looks like yours just happened when you did. Okay, mine is taking a little bit of time.
Okay, maybe you have a 386 computer, so give it time. With 2 gig of RAM.
Maybe he's using it to sell it.
It's done. It's done. I'm not using it.
But anyone else got that right? Were you able to clone?
Oh, yeah.
Oh, beautiful. We're making progress. And in fact, even if we don't go beyond this, we are fine, because you have been able to clone the central record just by that. All right. So while we're waiting for that other clone to complete, let's just revise it. So I have that. Then we went to Visual Studio. So if I didn't want to work as root, I could do sudo pass. I could do what? Sudo. And then the first I had to ask for my password, I have it. So we practiced sudo apt update, and then sudo apt upgrade, and then we checked the version of JIT. We found that JIT was already installed. Well, JIT was not installed. Then we'll do JIT apt install JIT. And then we went ahead to clone the repository that this was the old one we used in our old class, but this one will be new, the new one older. And you were able to clone it better. All right, that's beautiful. That's beautiful. Okay, so that's where we are. Okay, but in your own case, what I need you to do now, let's do it together. You have a copy in your local repository. Let's check our local repository. Let's go to gis ls minus ls. This is our local repository, the .git. We'll do cd.git. I think I'm going too far for one thing. Let me just finish this and then we'll stop learning new command. We'll just revise what we're doing. All right, so we're now in .git. ls minus l. We see the local repository. Branches, config, description, head, hooks, information. This is the local This is the local repository. So right now we have three different repositories. We have the local repository, we have the working directory, the directory from which we are working, and then we have the central repository. We have local, central, and in between the working, in between the local repository and the central repository, the cloud, we have the working directory. All right, we'll talk more about that. I just needed you to know that there is a directory called .git, and that these files there form different from this directory from which we are working. All right. Okay, let me show you one more thing for your own repository. Go to your repository. This is my own repository. Go to your repository. Your repository is empty, right? There is nothing there, right?
Yeah.
All right. So in my own case, I have one repository, DevOps project codes. Do you have any in yours?
No.
All right. So now let me show you how to create a repository so that you can push this, your codes in your local repository here to your central repository. So that way you know how all of the 3,000 developers push their codes to central repository, the same way you are going to do it. So let's go. You come here and you say, maybe I should even delete this. Let me delete it. So I click this and I go to settings. You don't have anything to delete, just watch how to do it. I go to settings, I say delete, this is my repository. And it says, are you sure you want to delete this repository? Type it by yourself. I said, I'm sure. My repository is gone. So I'm like you and I don't have any repository. Do you know what we want to do? What we want to do is, we want to push this local repository, this working directory, local repository to cloud. Where's our cloud? GitHub. So that we'll now have a copy in. Is that clear enough?
Yes, sir.
All right, so this is the way to do it. Click repository, and then you click new. What name do I want to call that repository? Let me give it the same name. What's that name? Let me give it the same. Control C. Control C. For consistency, I'm giving the same. Control V. All right. Description, just give it a name. I mean, if you, it's optional. Then you leave it as public. I mean, since you don't know how to use private. In my case, I'm leaving it as public so that all of my trainees can access it. If you want, you can say add a README file. That's optional. But ultimately, what you want to do is create repository. So you click create repository. So did everybody get this part?
Yes.
Yeah, you may use that or you may use a different name, but I just prefer to use the default. So I use that. And then that's all you have to do. But if you wish, you may just click add the README file. And then say create repository. So you see that repository has been created for you. So this is the repository. Or it's just like creating a directory. It has nothing inside. It's empty. So now let us push. We click that repository. Then there is nothing inside. The repository just created. Nothing is. Okay. Somebody should give me a small literature that I can read to know the next thing. But don't worry, I'll show you the next thing for you. All right. Now, I'll come here. Let me not waste your time. So I'll go here. CD there. LS minus L. All right. So this is my repository. So why don't I go into my repository? Because I want to push everything that I cloned before. I want to push it. You want to push now into your own repository so that you have this code both in your local and your central repository. That's how coders do it. So this is the command. Can you see my notes? To push an existing repository from the command line to push an existing repository to your central repo. In this case, our central repo is Git org. This is the command. We say Git remote origin, then you connect to the repository. All right, so let's see. So we'll come here. This is the repository, open, right? So we'll come to code again. We'll copy the HTTPS. We'll copy. We've copied now. So we'll go to our VS Code. I will say Git. I'm just trying to tell you the origin of this Git remote add origin. In fact, it should show me. Why is it not showing me that? So that you don't even need to. You don't even need to bother about remembering that.
Is it because we haven't installed the extension?
No. Are you seeing it in your own case? Is it showing you anything here?
No.
Let me look for a way to bring that up. So I just copy and paste instead of. Okay, so. Clone, open with GitHub, get Git. Okay. I saw it earlier. Okay, so luckily for you, I have it already copied. So I just this HTTPS. Where did I get it from? I copied it from there and I just put it here. Paste, Control V. That's all. So I now copy this command, Control C, and I paste here. Finish. Control V, and I press Enter. That is it. So what does it do? It has established a connection between this my Git and the one in the central repo. Git remote add origin. All right. Then the next command I want to do is, as in your note, and I'll say Git branch -m main. Control C, copy the command, and come here and paste Control V. And press Enter. It's done. And then the last of the three commands is to say Git, in fact, just copy it. Git push -u origin main. Control C, and then you come here and you say Control V. All right. Does not mean Git push -u origin main. Source ref spec main does not match any. Fail to push ref to that. Okay. I guess I'm in the wrong direction. All right. So let's try going into here. So if I refresh here, nothing is happening. Okay. So let's do it again. So when practice LS, of course, you can already see here, but if you are used to We can actually close here so that we are even blind to that. ls minus to cd dev. This is the directory. All right. This is where our project is. So go in there and then ls minus la. Yes, this is what we want to copy. So let's quickly do it. To copy this, to push the whole content, we follow this. We follow this command. First command, Control C, one by one. Control V. Remote already exists. Okay, no problem. The next command, what is next command? We copy that, Control C, and then we'll come here and say Control V. All right, and then the last command, push Control C, and then we come here and say Control V. So it's asking us for our username and password to perform this task. What is the username of my GitHub account? The ITern. So in your own case, you enter your own username. Or if you don't have if you don't remember your username, you can use the email address that you used to create your GitHub account. So I press enter. Where's my password? This is where you need your token. So my own token is saved right here because I'll be using it over and over and over. So I take my token, Control C, and I come to my CLI, I right click and I press enter. All right. That's what it should normally be, but I'm having this problem because of the name. Okay. Okay. Yes, I can resolve this, but it's going to take some commands, and you have not even learned commands. So, but in your case, you shouldn't have the problem because you have not deleted your system. All right. So, can you follow these commands to complete the cloning of your? No, you're already close. To complete the pushing of your local record.
Okay, so I think I had the same error you had when I tried to push the U
Okay.
origin. Yeah. So
Okay.
yeah, what did you CD to? Sorry.
Sorry?
What did you CD to before trying it again? CD to
Your local
like
directory.
the main. Okay, from the okay.
The working directory. So my own, I CD into this. That's the name of my working directory. Did anybody successfully push? These are the commands to push right here in front of. All right, so CD. Yeah. Has anybody tried these 4 commands? Okay. So maybe we are taking it too far on the first day.
I think I'll work on the notes.
Okay. All right, no problem. I'll repeat that because maybe all right, but everything is good so far. Like I said, I've not able to taught you the basic command, so it will not be right to teach you the complex command I will resolve it. All right, but earlier on, I successfully did that, and that was why we had the one that we did. All right. So what are you able to do now? At least you are able to set up the process so that you're able to clone a repository in GitHub to your local repository. The next thing we're trying to do was push this local repository to your own We'll continue from here. Any question? All right, so as you are continuing with the notes, my central repository is still there for you. Oh, it's not there anymore. Because I just so what I'll do is after class, I'll make sure I pump it back. Okay. I'll just make sure it's there so that you are able to clone, because the one that you should have cloned, I've deleted it. I'll bring it up back for you. So that you're able to come back here. How to clone the original. All right. Any question? Any question?
No.
Are you sure now? You just okay. Anything we need to revise to at least help you?
We need to listen to the video.
Huh?
We'll listen to the video again.
Okay. All right, so I'll let you do that, listen to the video, and then we'll come back to class, repeat some of those things, and then move on. All right, guys, so that's enough for one day, right?
Yeah, what a long 3 hours.
Long, right? Yeah, it was long, especially that first 1.5 hours of talk. All right, please watch the video so that you have the opportunity to ask questions about things you are not clear about. Then we can now build on that good foundation. If you don't watch the video, you not no questions for us. So once we move on from there, the foundation may not be there. All right, guys. So I'm still here supporting. If you have any issue, post it on the forum. That's it for tonight. Bye.
Thank you, sir.
Good night, everyone.
Yeah. Good night.
Thank you, sir.
Good night. Thank you, sir.
You're welcome.
Bye, sir.
Thank you.
Bye.